Hello everybody, this is Mr. Lowe. So I just wanted to make a quick introduction to a video that I made a couple years ago. And then past me, we'll take you through some examples. What we're going to be working on today is mixed naming. And by that, I mean naming where all the things are mixed in, including the covalent stuff that we learned recently. The problem with once we learn covalent often is we learned about the prefixes and people start trying to throw prefixes everywhere. People don't know when to exactly use the Roman numeral and everything gets all mixed up. So what you have here is a flowchart. This flowchart is also available on Schoology, and this is definitely not intended to teach you everything you need to know about naming, but rather it's trying to just get you in the right frame of mind for the things that you're going to name. So it's basically a series of questions that you ask yourself. The first question is you ask yourself, is there a metal present or the polyatomic ion in H4? If the answer to that question is no, that's when we're doing the covalent compounds, that's when we're using prefixes and nowhere else. If the answer to that question is yes, the next question you ask yourself is, where is this metal on the periodic table? Is it one of the ones we labeled? Is it in group 1? Is it in group 2? Or is it specifically aluminum, zinc, or silver? It's just those that, if it is in that area, the answer to that question is yes, then we're not going to use prefixes, we're not going to use Roman numerals, it's just going to be plain. Whereas if the answer to that question is no, that's where we're going to use Roman numerals. So again, it's just trying to get you in the right system of naming. It definitely works a little better when you are given the name and asked to, or rather given the formula and asked to write the name rather than the other way around, but it's still helpful in getting you in the right frame of mind. What I'm going to do is do a couple of really quick examples, and then past me will take over and do some more. So, if I'm doing these and you feel like you get it, feel free to, work on what you need to work on as far as finishing the naming. But, if you need help, stay tuned and watch all the examples that you have. So, for instance, if we were to look at these ones here, barium chloride. So, I'm looking at the metal here. I'm looking at this compound, and I see that the first thing listed is a metal. However, barium is in group 2 here. So the answer to that question is yes. So this is going to be just the plain naming there, where I'm not going to use prefixes or anything like that. In that case, this first one would just be called barium chloride. My second one there, I'm noticing that these are both nonmetals. Both carbon and hydrogen are nonmetals. Despite hydrogen being over here, it is a nonmetal. So what that tells us is that neither thing is a metal. So this is a covalent compound. Here's where we're going to use prefixes. And the prefix for 3 is tri, so that'd be tricarbon. And the prefix for 6 is hexa. Hydrogen. Remember, we always change the last syllable of the element to end in "ide" in the second part of the name there. So instead of hydrogen, it's hydride. Cu2CO3. Okay, so Cu is a metal. Yes, but it is not in group 1, 2, or aluminum, zinc, silver. So it's going to need Roman numerals for the charge of the metal. We're not going to use prefixes here. So this one also has a polyatomic ion. That's a polyatomic ion called carbonate. Now, I know that because I got it memorized, but you might have to look it up. So if we diagram this out here, you got a Cu. Well, you got 2 Cus actually attached to the CO3. I know that the CO3 is -2. That means each one of these Cus must be +1. So that would be called copper 1 carbonate. Last one I'm going to do from now, and then we'll see some more on the old ones. So this one is, every once in a while, you're going to see ammonium. Now that's the only way we can have a ionic compound without a metal present. See how it says ORNH4+. So there is a metal present, ORNH4+. So really, it's not super clear from the flowchart, but we're just gonna name this straight up. That's called ammonium. The other part here is called nitrate. So this is 2 polyatomic ions stuck together. This is ammonium nitrate. Okay, so I'm going to turn it over to myself from the past. I'm going to suggest a strategy and another a little bit more strategies, see some more examples. So thanks for watching, and I hope it works out for you. This one, which is where we have all of the types of naming mixed together. So that makes it even a little bit more challenging. So again, I would suggest, especially on this top part, we're going to use that flowchart to help us. And note the instructions say, on this page, circle the number of all of the covalently bonded substances. So how do we make that decision? So remember, whether a metal is present or not is the key. Or technically, ionic compounds can sometimes contain ammonium, like we just saw. If the answer to that question is no, it's going to be a covalent compound. If the answer to that question is yes, it's going to be an ionic compound, and we're going to be over here. So like, for example, in the case of this page, I would definitely circle these two. Now, that's not all of them. There's more, because I want you to look and do some of it on your own. But both of these are nonmetals, as are both of these. So those are covalent substances, and I'm going to circle those. Now, one strategy I might suggest to you, and I'm just going to look at ones from the top half, sort of, just to give you some decision-making to do on your own, is go through all of them before you even start. Decide the type of naming system that you're going to be in, and then maybe name all those at once. Like, do all the ones with prefix naming, and then get that out of your system, and then you'll know, okay, I'm not going to do any more prefixes now. So this is what I mean. For example, with covalently bonded substances, that is the only time we're going to use prefixes. So in the top half that I've drawn here, again, not on the whole sheet, but just in the top half, these are the ones that I'm going to use prefixes on. So I would indicate a little P there, and now none of the others in this top half are going to use prefixes. The next thing I might want to find is which ones need Roman numerals. So remember, the Roman numerals are going to be, if the answer to this question is no, is the metal in group 1, 2, or aluminum, zinc, silver? So neither of these two need Roman numerals, because calcium is in group 2. It's in the second column of the periodic table, and potassium is in group 1. So therefore, those aren't going to have Roman numerals, but copper will. Copper is in the middle. Copper is right here. That's going to need a Roman numeral. So maybe I put a little R there and to indicate that I need a Roman numeral, and as does lead. Lead is in group 14. So it is not in group 1, it is not in group 2, it's not one of these three, so that it's right there. And then none of the other ones on this top section are going to use Roman numerals. So therefore, that leaves these last two, which are just the plain naming. So then I would suggest that you just go through and name them one at a time. So like this one, that's going to be iodine tetrafluoride. So we use prefixes here. This one is going to be carbon monoxide. Now I'm done using prefixes on the top half, so I'm going to get that out of my system. I'm never going to use them again. And then maybe I name both the ones where we have Roman numerals. So this is copper, so the sulfur is -2. So that means that this copper has to be +2 to balance out that -2. So that's copper 2 sulfide here. Okay, this one has a polyatomic ion. I can tell because there's more than 2 elements here. I have to look up the name of that polyatomic ion if I haven't memorized it, and also its charge. Its charge is -2, and it's called carbonate. Now, this is one of the tricky ones. Notice that there's 2 carbonates. So there's a total of -4 of worth of charge coming from those 2 carbonates. That means this lead has to be +4 in terms of its charge, carbonate. Okay, and then these would just be the plain ones. They don't have any prefixes. They don't have any Roman numerals. So that's calcium fluoride. Notice no prefixes there. Difluoride is wrong. Potassium fluoride. Okay, so then if we're doing the bottom half here, and again on yours, I believe this is all on one page, and mine's kind of split up. You know, keep an eye out for the prefix-based ones. So again, we'll just kind of look at, I guess we'll look at this, this top half. In the top half above here, the only ones that has a prefix is this one. Then we would want to keep, from there, we'd want to keep out for any ones that we see Roman numerals, which there's no in this top part that I've circled here. Then we want to keep an eye out for polyatomic ions. Polyatomic ions are going to end in ite or ate with a couple of exceptions. So that's a polyatomic ion. Nitrite is NO2, -1. Hydroxide is the one of the two polyatomic ions that ends in ide. But here, when they end in ide, that's just going to be regular O-2. So calcium oxide, since calcium is +2, would just be CaO. Aluminum oxide, Al is 3+. Then we got the oxygen. This is going to be one of these where we're going to have to go like this. Lithium nitrite. Lithium is in the +1 column. I just want to break in very quickly to say past me made a little bit of a mistake there. I was saying everything right, but for some reason when I wrote it as nitrate, when actually it should be nitrite. It should be NO2, not LiNO3 as I wrote in the other video. So it would be like that. Magnesium hydroxide. Magnesium is +2, hydroxide's -1, so I need 2 hydroxides. This is where you need parentheses, when you need more than one of a polyatomic ion. On hydroxide in particular, people tend to forget the parentheses. And then xenon tetrafluoride. So remember, when you see the prefixes, just write down what it says. Don't worry about anything. Don't worry about charge balancing or anything like that. Okay, so I think that's it for now. Hopefully that gives you a fighting chance to do this. Be sure to reach out if you have any other questions. But other than that, thank you for watching and have a good day.